Thank you, Wim. Thank you all for coming. Thank you for all these labels to have us the first WebDriver meetup that we ever hosted, I think, the official ones. So it's great to be here, great to give a talk about WebDriverIO and what we want to do with the next version and demystifying how we want to integrate into WebDriver Bidi. So this is the talk will be about. Before we start, I don't know what you heard, if you follow WebDriver and what we do. We recently launched a shop basically to help us a little bit, to help give you some cool swag and kind of like support the project at the same time. We released some t-shirts. They're online, so if you buy a t-shirt, then some of the money will go into the project and help us to run things like this. Today, thanks for all coming. We want to do a little like tombola. So I got the list from all people that showed up today, and I hope we can just find someone who I have a t-shirt with me to take home right now. If the person wants to have a different t-shirt or a different color, we can give a coupon so you can get the t-shirt for free. So we'll see who wins. It's gonna be Poonam. Do we have a Poonam here? All right, I guess 3, 2, 1. Poonam on toilet? No. Okay. Let's spin the fortune wheel again. And we have this time Guido. Do you have a Guido here? All right. I will come up later and we can exchange the contacts. And then you can get either that free shirt or you can get a coupon to get a t-shirt for free. Cool. Congrats. So the agenda today, I will shortly talk about the kind of like state of the union, like talk a little bit where WebDriver comes from, where we are right now, and kind of like what we want to do in the future. We'll talk about automation strategies as like an introduction about what is WebDriver and what is WebDriver Bidi and how it relates to the other automation frameworks that are out there. And then we show some of the new Bidi features that we're going to integrate into WebDriverIO and what they will enable and how we kind of like, how we embrace WebDriver Bidi to make these features possible. There are some interesting hacking ways that you might find interesting. Starting with the state of affairs, WebDriver, I started working on it as part of like a college project where our professor said we have to test the software, and it was a single-page application, and that you cannot test with unit tests. So I used a project called WebDriver.js back in the days, which we then renamed to WebDriverIO. At some point, we moved that project to the JS Foundation, which is today the OpenJS Foundation. It's kind of like our family where we have other projects like Node.js or Mocker. It's part of the umbrella of the foundation, and the foundation kind of like helps us to manage the project, get us away from any all the organizational stuff like code of conduct issues. We have all processes in place for that, and kind of like helps us to run the project. If you have a big open source project, you want to make sure if you don't want to get sued, and the foundation helps with that too. So then in 2018, we kind of like were the first people or the first project that adopted the WebDriver protocol. Before it was the JSON wire protocol, which was a protocol defined by the Selenium project. And then everything kind of like became standardized. Wanted to roll this out to all browser vendors, and the browser vendors actually started to work on this specification to make sure that we can automate browsers across all browsers that are available in the same way. And since like 2018, we actually started to talk about WebDriver Bidi, because when the people defined the WebDriver Classic protocol, kind of like in 2015, people started to work with frameworks like React or Vue or Svelte, and that kind of like created a new kind of wave of how applications are developed, move away from server-side execution towards like everything is happening in the browser, and that started to create some new demands on how we needed to test applications. So new thoughts about how we need to automate browsers started to evolve, and we kind of like tried to bring this all into the new protocol. Today, WebDriver has about 1.3 million monthly downloads. It has 8.7 stars on GitHub. We secured some funding to make the project development sustainable, so we can run events like this, help the community. We actually, like, if you post a PR on GitHub and help us fix a bug, you will get paid out immediately for every PR. Flat out, you can make a little bit of money on the side, and if you become more invested in the project, you become part of the team, you actually can earn up to $50 an hour or $80 an hour. And we want to kind of continue raising money to be able to run a sustainable open source project, because we don't want, I'm a big fan of that kind of projects that are not run by companies that eventually decide at some point to not fund the team anymore that works on a certain open source project and then have it die, which what happened with Protector. We want to have this project basically run forever in a sustainable and healthy way. We have about 3,000 unique website visitors, 1,500 Discord members. Before we moved to Discord, we were about 8,000 on GitHub. About 540 contributors, which is, if you compare this to the other project out there, the biggest numbers that you see by far. 68 project members that are now part of the WebDriverIO team and help out in various ways. We have someone who's solely focused on the Electron plugin. We have people like Wim who help us out on the visual side, on the mobile side. Like, there's problems and things people can work on in many different shapes and forms, and we still look for people that are interested in helping us out. And we have about a big ecosystem of projects and plugins and reporters that you can use, so you should never have to build this yourself. You can just use some existing stuff that is out there. What's happening in the future, or in the recent past, we introduced component testing to WebDriverIO. So we didn't want to only focus on end-to-end tests. We want to allow you to test your components in the browser. So WebDriverIO actually can now run in the browser, which is interesting for many reasons, but mostly because you can now say, okay, you can basically remove a lot of your end-to-end tests and just focus on the UI and component test, mock your backend out, and just make sure that the UI work, and at the end, just run a minimum set of end-to-end tests that really require all the components to be together in one, because those ones are usually the ones that are brittle and flaky and fail a lot. If you focus all your efforts on writing tests on the UI level, you can run them much faster. You can have much more coverage because you can tell the backend or you can fake a backend that responds in certain ways, and you have much more flexibility when it comes to testing. As I mentioned before, we've secured some funding for sustainable development of the project. We consolidated the ecosystem. Like, Wim contributed all his visual projects to the WebDriverIO organization. So we have now visual comparison, screenshot testing built in, basically. I just saw yesterday the first time the storybook runner testing the whole BBC style guide. It's like 200 components within 12 seconds, which is pretty cool. We do some more development on that front as well. We tried to catch up some features. We introduced DOM snapshot testing, and you can now do snapshot testing across when you do component testing or end-to-end. And we're continuing growing the community by running these events. We will be tomorrow in Waldorf at SAP. Next week, we're going to be in London to speak to the community and talk about WebDriverIO. But let's get into browser automation. When it comes to browser automation and working on WebDriverIO, we always think about how browsers can be automated today. And today, it's mostly categorized in 3 different categories. It's WebDriver-based, emulation-based, and DevTools-based. Who of you thinks, in what category do you think Cypress belongs to? What do you think Cypress does to automate the browser? No cheating here. JavaScript. So what do you think?
The emulation-based.
That is correct. When do you think about Nightwatch? I'm not sure if everyone knows about Nightwatch. Nightwatch is WebDriver, is based on Selenium. Puppeteer? DevTools, that is correct. Playwright? DevTools, that's correct too, with a star because Playwright kind of gives you browser patches. So it's not pure DevTools. They have their own extension on that. Next would be Selenium. WebDriver, that's correct. And lastly, WebdriverIO. That's correct. Actually, in fact, some of the tools like WebDriverIO, Selenium, Puppeteer is now adopting WebDriver Bidi and tries to move off the CDP completely. WebDriverIO does some DevTools interfaces, uses some DevTools interfaces as well. When you use a DevTools plugin, which will be the Lighthouse plugin, you have some Lighthouse integration to test performance or test if your application is a valid PWA application. This is all runs through the DevTools protocol. So you cannot really categorize them in one category only. Some like bridge into other technologies. So the WebDriver protocol back in the days, I think they started to standardize this in 2012. The design of the protocol was to allow to automate a browser with you can do whatever a user can do. So you can navigate to an URL, you can click on a button, but that's it. And back in the days, it made sense because most of the websites were rendered in the browser, and you get like a static HTML, and that's it. There was almost no JavaScript to be involved. And that idea works because you can say, you have a test script that say, hey, go to my test page, and you have someone who understands that command and can go to the factory to execute the command. The factory can be a browser, can be a mobile device. And this is nice because the factory can be anything, and you just need this translator that goes to the factory and executes the command. The translator here is a browser driver. For every end device, you have a driver that can execute the command. For Chrome, it's Chrome driver. For mobile automation, it would be Appium, and there are some others. But you can see that with WebDriver, you give that person a command, it runs to the device or remote end and executes it there, comes back with the result. This can be slow, right? Like for every interaction, depends on your network quality, it can take some milliseconds to execute, right? That's why in a lot of blog posts you see WebDriver or Selenium is a slow protocol, which I would say it's not quite true because you can parallelize this execution 100 times. When I worked at Sauce Labs, we had customers that ran 500 tests in parallel. And even though these commands, in itself, they were slow, but if you parallelize everything, it can be quite fast, and you can get quite a lot of coverage. So the way it works would be you have WebDriverIO, where you want to execute a click operation. You have a driver, which is the little person that translates your command. And you have Chrome. You create a command is essentially a package, a network package that has a URL. The WebDriver protocol is like an API that you can call to execute a command. For the click command, you have this URL that contains a session ID, which essentially points to the browser that you want to automate. And for the click command, it's the element ID, which is the element that you want to click. It's a WebDriver package. It's a fragile because if your internet connection breaks, the automation breaks as well. But what you do is you send the command to the driver, and the driver then translates the command into whatever it needs to do to automate it in the remote end. In this case, it's Chrome. For Chrome, we would use Chrome DevTools protocol. You're probably familiar with that. The driver itself, though, it does not send one command to the Chrome browser and sends back. The driver itself is constantly connected to the browser for many reasons. One is just to check if the browser is actually still around, still accessible or not. And so it does a lot of things. It uses Chrome DevTools, sending a lot of packages to the browser. For the click command, essentially, it calls a function in the browser with just return me a 1. That just to make sure that the browser is accessible and the frame is accessible. Then it tries to get the page frame, tries to figure out where the button is located or the element is located. It figures out with the call function, with some JavaScript, it figures out if the element is not obscured by some other element, if it can actually be interacted with. That's part of the protocol for every interaction that you do with an element. And then it sends some events to that particular element, a mouse moved, a mouse pressed, a mouse released command to do the interaction, and then it still again evaluates if the browser is accessible. And after that, it sends the results back to the driver sends it back to WebDriverIO, and then we have a successful command. That's essentially WebDriver in a nutshell. Now with WebDriver Bidi, things changed a little bit. When we started discussing the protocol, we were like, okay, we need to give the browser a little bit, the user, the automation, the tester, much more capabilities, because now with React, with Vue, with Svelte, there's so much more requirements that people have testing applications that we have to give them a little bit more power. And so with WebDriver Bidi, you as an automation engineer, you sit on top of a little village, and you essentially have access to just a bunch of things in the browser. You can not only act as a user, you can now introspect the browser a little bit more closer, and you have more access to the browser from the begin with. And you kind of like talk to different domains of your world, which can be the browsing context, which can be the network, which can be the logging module, sort of like kind of different domains around the browser. And at the W3C, where this is being standardized, we talk to the browser vendors and kind of like find a common subset of all browser DevTools protocols that are around and try to find, okay, what makes sense to use in WebDriver for automation purposes and what doesn't. Now with Bidi, most of the things stay the same. You have a driver, you have a browser, and you have WebDriverIO. But now the package looks a little bit different. You don't only send a HTTP request. You now have a constant connection to the driver as well, since you send socket messages back and forth. And a socket connection, for instance, for navigating to a URL would be this. You have a method with some parameters. And for this particular one, you see in the parameters, you have a context. And the context is interesting because now we can able to talk to different tabs at the same time. Before, in WebDriver Classic, you would have to switch to a different tab. With WebDriver Bidi now, we can basically automate in multiple tabs at the same time, which gives some capabilities to do parallel testing in the same browser if you want to do that. And you just open one browser, open 100 windows of that in one browser session. You can automate that if you want to. It's a Bidi package. It's still fragile because it's a network connection. But now with Bidi, WebDriver will be also more connected to the driver. It doesn't only send one command after another. It will be constantly listening on events because it needs to understand the state of the application at all times. And on the driver side, everything stays the same. There are multiple connections. Stays connected to the browser at all times. Now, if you look at the protocol, I'm not sure if you ever looked in like how web's technology is being standardized. You see that there's a bunch of like new modules that are being created for creating a session, for allowing to create a user context, which is basically a different tab or frame to navigate to. We have now events and commands and types that are defined here. We have a network module, which allows us to have access to the network. We have a script module, which allows us to have access to some scripting capabilities. And we have a log module and an input module. And this is just like the beginning. The driver vendors actually meeting every month to discuss potentially new commands that they can add. And they're currently in progress of implementing all of that is already defined. But some of the stuff that is kind of like interesting for us, one, the log module. Before, we never be able to tap into log events in the browser because we would have to constantly pull them, and the browser driver cannot just constantly store log information on the driver side. So now with the event system that we have with the bidirectional connection, we can just constantly listening on events, and the driver can just release them to the listener and doesn't have to store them. The add preload script is very interesting because now we can access the application or the website before any of the other stuff is being loaded. And that allows us to do very interesting emulation, or like, you can create a system, or we can create an environment that is where WebDriver can tap into more information. And I will show you some examples in a second. There are some serialization options. The WebDriver Bidi has defined a way to look up elements within shadow DOMs and closed shadow DOMs, shadow roots. So that will be interesting. And there's new locator types, and what I mentioned before, the network interception, which I'm going to show you in a second.
Yeah. What's the idea for the future? Is is like adding extra functionality to the WebDriver protocol, or it's of course a different spec, but or is it to replace the existing WebDriver spec?
Good question. The classic WebDriver will always stay around for the foreseeable future. So that's what I mentioned here. With WebDriver Bidi, you can opt in to that protocol. With that little WebSocket URL true, you can say to the driver, hey, I want to listen to events, I want to use the WebDriver Bidi protocol. But for the foreseeable future, most of their commands will still be run on WebDriver Classic for the ones that make sense to be on that, stay on that protocol. They are not, they are thinking about translating all the commands over, but for now we remain on the WebDriver Classic and tap into Bidi whenever we need to and want to. So with that socket URL, you will access to already today access the Bidi protocol. With version 9 that we ship in a couple of months, this will be the default, so you have to opt out if you want so. For instance, one example would be to tap into logging if you want to find out if your application is throwing any errors or does any console logs. You can now subscribe to events. This is basically tells the driver which events it should pass to the driver. This is just a protection mechanism, so you don't DDoS yourself by listening to everything that's going on in the browser, which can be a lot. Once you register the event, you can start listening on that event with a simple event listener. And then in this case, to trigger a console log, we call the execute command and run something in the browser, the console log in this case. So this is a very simple example how you can now get like this kind of information where you get even the stack trace, where the log has happened or where the error has happened and what kind of like error has been thrown or which kind of console log has been logged out. Another example is the add preload script. I mentioned that before. It gives us a lot of opportunities now to do some various of emulation things. In this case, we want to emulate the geolocation, and what we do here is we inject that script, which is again executed before everything else is executed. And what we do is we override the navigator geolocation interface from the browser. And instead of running the original command to get the real geolocation, which for testing purposes is not interesting, we can allow the user to predefine a geolocation. And that actually works on I have a Google Maps example where this works. And it, of course, depends on how your application receives the geolocation. If it does that through a header, it won't work. If it does it, even then you can do the network interception, but if it gets it from somewhere else, then it won't work. But if you use the geolocation API from the browser, this would work. Another one is changing the user agent. Same approach here. We override the navigator user agent property and just allow you to return whatever you want. And this will be it. Another interesting example is piercing into shadow DOMs. Who of you have ever tested an application that had web components with a shadow DOM? And you all know it's kind of stressful to have to go into the shadow root and all this switching back and forth. Now with WebDriver, with Bidi, it allows us to kind of do a little tricks to not have to do this anymore. For people who don't know, if you use web components have their own encapsulated DOM, which you cannot immediately tap into. You have to look up the component, and then you have to access the shadow DOM, and then from that you can look up into the component itself. So if you would now in WebDriver version 8, if you have this DOM tree with some custom components and some divs, if you would like to look up all the buttons, like these two in the bottom, you would find no button because they are obscured behind this custom component and this custom component. So we would only access to that point. And if we want to actually find this button, we would have to look into the shadow DOM of that component, find this element, have to look into shadow DOM of that component to find this element, which is kind of tedious. And I think one of the reasons why web components really have taken off so far, if you use React, you don't really use the shadow root. You use the React version of encapsulation. Now, WebDriver provides some primitives to access the shadow root. You can use the shadow $sign to kind of traverse into into the target UI element. But that can be problematic if you dynamically change the location of the element and it's out of the sudden in a different custom component. And then this won't work anymore. In order to kind of like fix that, what we tried is we used the script command to inject some JavaScript before the application is being loaded. And we override again the custom define method, which you use usually to define a custom component in the browser. And what we do here is we create a custom class that extends from the class that you want to define, and we just use the connect and disconnect callback to lock the shadow root and the component that is being registered, just log it. And when we, at the same time, use the log module to listen to these log events. And WebDriver does the translation of, instead of returning the node, the DOM node, it returns the reference that we can use to actually access the element later on. So this will allow us to kind of like pierce through the shadow DOM, because now we know all the shadow roots, and we can do a parallel lookup on all those custom components at the same time, and one of them will give us one of the buttons. Yes?
Is it very costly performance-wise?
It is more costly, yes, because we have to, especially if you do the lookup from a custom element. Let's say you have this element and you want to find a button starting this DOM root. Then we have to kind of like traverse back up to see if this element is the parent of this element. So there are some more commands happening, but it's marginal, let's say. And we try to optimize it. Like we have somewhat a finished implementation right now, but I already have ideas to kind of like store the shadow implement or the shadow root in memory and make this very efficient. Yes.
So you implemented this just to get an idea from what the shadow root is?
Correct.
Is this like a default? Is it being introduced to script by default?
This is what WebDriver does under the hood. This is what you don't see and what you not have to care for. You just use the $ commands, and it works out of the box. WebDriver just keeps tracks of which shadow roots are available or registered on the page, and stores them in memory, the references. And basically, if you look up an element, it looks up in all shadow roots at the same time.
But you're using a class that you're like overriding a class just to get the information?
Yes.
Is that class also being used, like maybe if you're on a project where you're doing some custom stuff, like devs really like to do, they override this class themselves? Would that then cause an issue?
It should not conflict, or it should not conflict in any way, because we basically just extend from the class that you put in, and we like use these lifecycle methods, which we call with the same commands, and it should not like cause any interference with whatever you do. It would surprise me if it would. So now there's one problem though with this approach, is there are two types of shadow roots. There's an open one and closed ones. This one that I just showed works for open ones because you can access the shadow root through JavaScript. If you close them, you don't have access to the shadow root at all. So this kind of example doesn't work anymore because this .shadow root will return null, and then we don't have the information anymore. So I went back to the drawing board and was like, okay, what needs to be done to fix that? And so we found another trick where we override the attach shadow method of the element class. And basically, whenever you call the attach shadow, we will kind of like lock the shadow root that is being returned from the original command, and then just lock that. And that will give us access to closed shadow roots, which no other framework so far that I've seen has the ability to do so right now. Right now, many frameworks, they just run JavaScript to query elements. And now with this approach, we just get access and can use XPath query. We can use link text queries. We can use all the queries that we normally used to do with the same way, but in all shadow roots at the same time. And yeah, if we get around to kind of like optimize I mean, it's a simple like graph problem, right? Like if we can optimize how we can create this graph in memory and be able to do these lookups in memory, we can save a lot of like WebDriver commands as well, and make this operation very efficient. So this works. Another problem with web components is if we want to log the HTML of web components, we also don't get this information because the HTML is part of the shadow root, which is not exposed. If you do like a get HTML of a web component, what you get is nothing, because there's no, unless you have a slot, like something within the web component, you don't get anything back. Now with WebDriver version 9, we will be able to traverse all the HTML of all these shadow roots. We can fetch the HTML of them in parallel and kind of like stitch the HTML together and create a declarative web component, as you can see it here, and be able to give you ability to kind of like create snapshots on these web components. Another thing that is interesting to look at is the script call function, and I'm not yet sure what we can do with it, but something that's really interesting here is that include shadow tree, which is non-open or all. So hopefully all what I just said won't be necessary anymore, because we will be able to just call a script and access all the shadow roots automatically. But this has been, and what I want to say is like this, the protocol is in progress. There's nothing finalized, and so a lot of things have been defined initially, but there's no concrete implementation yet. So we don't know what it means. But there's some potential interesting new capabilities to take a look for. Another interesting fact for Bidi is the Locator strategies. In Classic, you were able to fetch links by text, by partial text. This will, and can fetch elements by tag name. This will be removed. Now you can fetch elements by CSS locator, by inner text locator, and by XPath locator. And the inner text locator has some interesting capabilities where you can ignore the case. You can do a full or partial inner text location, like fetching, and there's a def property to it, so you don't, you don't look in too far and cause probably like performance problems. But there's some new locator that we will make use of and can provide that and or create some new features around that as well. And most interesting for me as well, personally, is like the ability to intercept network requests. We now have the ability to mock a certain resource and introspect it before it is sent to the server and after it came back to the server, but sent to the HTTP client, whatever you use, or the fetch command. And again, before the request is being sent, when the response is being started, and for auth challenges, so basic authentication is now being solved with WebDriver Bidi as well, because now we can provide these credentials through intercepting the network request. How this would work is with pure Bidi commands, as again, you subscribe to events, which is the response started. So we want to modify a request when it came back from the server, for instance, to update the response in a certain way, or just to make it fail. And then we register a network intercept with a certain pattern, and there's some ways you can define the pattern. WebDriver will make it easy through globbing to define like various ways how you can define resources. But essentially, we say, okay, we want to, when the response started, we want to tap into the process and want to change the returned request or response. And then we listen on the event. We check if the request is blocked, because only the ones that we have intercepted are being blocked and we can modify. And then later on, we can provide a custom response. In this case, we can say, okay, we want to return a 400 if you reach out to that request, and give you a certain error. Now, this looks kind of tedious, a lot of like callbacks and commands. So we created a little like shorter interface to make this nicer. You create a mock where you can pass in your resource, some filters to it, and then you just say, okay, respond once or respond to all requests in a certain fashion. Yeah, we spawned once, or we spawned to all, which I hope will be very powerful. And you can do this for not only like end-to-end tests, but also when you do and write component tests. Which gets me to v9. I think there's a lot of, like, with the Bidi protocol now being adopted and more browser vendors ship more primitives for every version that comes out. There are some cool things that we have put on our roadmap and want to ship with version 9. Some of the things that we already have done is removing the JSON wire protocol, because that's a thing of the past. I'm not sure if any cloud vendor still supports it, or someone still uses it, but usually people have adopted WebDriver since it has been released 2018. We will remove the DevTools package, which we originally used to tap into CDP, but that with Bidi won't be that important anymore. So we will remove that package and we'll reuse it for something else. We're going to merge the is displayed within report with the is displayed to make the API that WebDriver provides a little bit more cohesive. We now use the native fetch method. That is general part of our effort of using the general web interfaces, which will help us to run WebDriverIO with Bun, with Dino, and other JavaScript environments, because those are the standardized primitives that allows you to just run JavaScript projects or libraries across all these different platforms. And we will drop support for Node 16 since it has been deprecated now. We're currently working on the Shadow DOM piercing. The open shadow root works already. Again, I've done some work today to make it work for the closed shadow root, but that will be released soon. We will do this automatic element lookup also for iframes. So you never have to look up an iframe, go into it, and then do a lookup again. Since we get the information whenever a document is being loaded, we have this information now too, and can tap into that automatically and basically use the same approach and idea to look up elements across all the iframes that you have open. We will rename the DevTools service to the Lighthouse service. The DevTools service used to have some capabilities to tap into the CDP protocol. That won't be necessary anymore, because we have an ability to give you a Puppeteer instance for that browser, and you can just use Puppeteer. So we will use the DevTools service for something else, and all the Lighthouse integration we have, we will just call it as a Lighthouse service. And we do some configuration validation, so you don't have any spelling issues with some configuration. We will merge the WebDriver element type with the chain promise element to fix some bugs in the way that if you would type, if you would chain commands on elements, you would get this weird bug in the IDE that it would automatically insert awaits in there, which were not needed. We do some TypeScript improvements, and we will probably work on an upgrade utility that helps you to easily upgrade from version 8 or wherever you are to version 9. With that being said, the version 9 effort is ongoing, and you can already use it right now, because we will probably not introduce any breaking changes, and you can start playing with these new Bidi protocols. Probably not, we'll see. But if you want to use the new Bidi features and the things that will come, you can use the next tag to already upgrade now and play around with it, and always feedback is welcome. And with that being said, thank you so much, and open to questions.